Myself Prabha Ranjay, working as an assistant professor in ECE department at SNS College of Technology. In this lecture video, I am going to discuss about the topic name is analog filter. From the subject name is a digital signal processor from unit number 2, that is IAR filter design. Let I discuss. Yeah. Filter can be classified into two types, that is analog filter and digital filter. Further, digital filter classified two more types, that is IAR filter and FIR filter. IAR filter in the sense infinite impulse response filters, length of the unit sample response of impulse response or impulse response h of n is infinite for the IAR filter. In FIR filter, that is finite value. The filters designed by considering all the infinite samples of impulse response. In design of IAR filter, the specification of IAR filter is transformed to specification of an analog filter and an analog filter with transfer function, that is H of S. H of S is nothing but the transfer function for the analog filter. Then the analog filter is transformed to digital filter with transfer function H of Z. We have two types from digital analog filter to digital filter. That type is, one is bilinear transformation technique, another one is impulse invariance method technique. Using these two types, we can change the filter from analog to digital. And some of the advantages of digital filter. Advantage over analog filter, digital filter over analog filter. The values of some components like a resistor and capacitor inductor used in analog filter changes with temperature, that is room temperature. Since digital filters don't have these components, they have high thermal stability. Also, digital filter are programmable, hence the filter coefficients can be changed at any time to implement adaptive filters. And in digital filter, the precision accurate of the filter depends on the length of the registers used to store the filter coefficient. And some disadvantage, that is bandwidth of the discrete signal is limited by the sampling frequency. The bandwidth of real discrete signal is half the sampling frequency. Also, the performance of the digital filter depends on the hardware, which means, for example, if you consider DSP, that DSP processor, in front of the beginning of the processor have A to D converter, and end of the processor have D to A converter. Hardware complexity is more than compared than the analog filter. Comparison, already we have discussed comparison between analog and digital, and frequency response of analog filter going to classified in four types, that is low pass filter, high pass filter, band pass filter, and band limit filter. In low pass filter, pass band frequency, that is allowable frequency, is low pass. In high pass filter, allowable frequency is high pass, and blocked frequency is which is called as stop band frequency, which is low frequency in high pass. When consider low pass filter, the stop band frequency is high frequency. And del p del s is nothing but the limits of tolerance in both del p in pass band, del s is stop band, and pass band magnitude is approximated to unity with error del p. Alpha p is nothing but the attenuation of the pass band. Alpha s is nothing but the attenuation of the stop band. Here you can see omega p, which is nothing but the analog frequency, analog passband frequency. Omega is analog stop band frequency. Unit of frequency is radian per second, and ap is nothing but the gain level. As is nothing but the stop band gain. Omega p, which means you can see here, you can see this omega is different from this omega. This omega, first omega is nothing but the analog omega, and second omega is the digital omega. Omega suffix p in the sense passband frequency. Omega suffix s is stop band frequency. And here you can see the ideal low pass filter response, both pass band and stop band frequency. You can see this is the high pass filter, and this is the band pass filter, and this is the band limit filter. And by using impulse invariance method, we can convert analog filter to digital filter, which means analog transfer function to digital transfer function. And the formula for impulse invariance method is 1 divided by 1 minus e power minus pk capital P suffix k capital into capital T z power minus n. By using this formula, we can convert the analog transfer function to digital transfer function. And relation between both analog omega in the sense frequency, analog frequency and digital frequency. Analog frequency is nothing but the digital frequency omega equal to analog frequency into capital T, and analog frequency omega equal to digital frequency divided by capital T. S plane to Z plane conversion means analog to digital conversions. By using bilinear transformation technique, we can convert from analog to digital filter by using this formula. S equal to 2 divided by T. T is nothing but the sampling frequency. 2 divided by T into 1 minus Z inverse divided by 1 plus Z. By using this formula in bilinear transformation technique to convert from analog filter to digital filter. This is the relation between both analog and digital frequency. This is the formula for relation between analog and digital frequency. And warping effect and pre-warping effect. For high frequency, in bilinear transformation technique, the relation between analog and digital frequency is non-linear. When the S plane is mapped into Z plane using bilinear transformation, this non-linear relationship introduces distortion in frequency axis, which is called a warping. In IAR filter design, using bilinear transformation, the conversion of the specified digital frequency to analog frequency is called pre-warping. Here you can see the warping and pre-warping effect through the graph. This is the assessment of this video lecture. You can note it down. Define IAR system and mention its advantage and disadvantage, and what is del P and del S. Compare analog to digital with digital filter, based on the frequency. What are the types of analog filter? Define bilinear transformation. What is mean by pre-warping? Okay, if you have any doubt, you can ask me through the comment. Thank you.